This is 6.1, continuing on, starting on page 6-4. We're continuing to work with the cosine function, so we're going to give some information about that. So let's review just a little bit. With the cosine function, we determined on the graph that if we restricted the domain from 0 to pi, this part of the graph, then it passes the horizontal line test. So then what we're going to do now is switch our x and y values so that we can come up with the inverse cosine, or the arc cosine. We can use the unit circle, and I'll use that also so you can see that it comes from there as well. Remember that if we wanted to write x is equal to cosine if we write x equals cosine of y, that means the same as y is equal to arc cosine of x, or inverse cosine of x. If we plug in these values for y, and then we take the cosine of them, then we're going to get these x values. Now remember, with the unit circle, I'm going to start with 0, going anywhere from 0 up to pi. We're just because that is what we restricted our domain to for the cosine function, so that it's 1 to 1. All of our answers for these x values are going to be within the first or the second quadrant. If y is equal to pi, we have cosine of pi. Well, definition of cosine is x on the unit circle, so we look for pi, and the x is -1. So we can think of it that way. Or if we started off with -√2/2, that's the x value. For -√2/2, we have 3 pi over 4. That's what we have here. We can go back or forth, it doesn't matter. I'll try going backwards again. If x is 0, remember that's the definition of cosine on the unit circle. So we look for where x is 0, that's here at the top. Then what is the number of radians? That is pi over 2. If we have x on the unit circle equal to √2/2, then the number of radians is pi over 4, and that's what we have here. And then going to the unit circle, if x is 1, that's the 1 for x here, then y is the angle, which is 0 radians. If we plot -1 pi, that's here, and then 0 pi over 2, and 1, 0, and then in between that you can graph -√2/2, 3 pi over 4, which is up here, and then √2/2 pi over 4, which is there. And that's what the graph looks like. For the domain, if we read it from left to right, we're going from -1 to 1. The range is from 0 to pi. And just like sine, this is what's important. You want to remember what the range is. That will help us. So we're finding the values. The inverse cosine function is decreasing on the open interval from -1 to 1. So you can see it's always decreasing, and then it's continuous on its domain from -1 to 1. It means you don't pick up the pencil from the paper as you're drawing the graph between -1 and 1. The x-intercept is 1, 0. That's here. And then the y-intercept is at 0 pi over 2. The graph is not symmetric with respect to either the y-axis or the origin. And it looks like we're going to do some more examples later on with the cosine function. Let's go to inverse tangent function. So the arctangent, or the inverse tangent of x, is equal to y, so we can write it either way. Means that x is equal to tangent of y. If we look at the graph of tangent that's over here, f of x equals tangent of x. Remember that it repeats after every pi. This is just a part of the graph, but do you see how this part from -pi/2 to pi/2, it passes the horizontal line test? And since that is the case, then we can just restrict it from negative pi over 2 to pi over 2 for the domain of the tangent function, which means that the range is restricted to negative pi over 2 to pi over 2. Now, do you see how we have asymptotes? That means that negative pi over 2 and pi over 2 are not included. It gets really close to those values, but it doesn't include them. The domain of inverse tangent, well, if we look at the graph here, the range of tangent, it keeps on going down, keeps on going up, so that's all real numbers. So negative infinity to positive infinity. Because remember, the range of the function is the same thing as the domain of the inverse. Let's go on to the next page. This is page 6-5, the inverse tangent function. We can write it either way. Remember, that means the same thing as if we have x is equal to tangent of y. Here's the original function to the right. Here's the restriction, our domain. And to find these points here, I will go backwards. For the function f of x, the domain, restricted domain is from negative pi over 2 to pi over 2. Looking at the unit circle, negative pi over 2 is coterminal with 3 pi over 2, and then pi over 2 is up at the top. So the two quadrants that we're dealing with are quadrants 1 and 4. 1 and 4, we want to remember that when we're using the unit circle. I'm going to go backwards and see, hopefully you'll understand how I'm using the unit circle to get these values. If x is equal to negative 1, and we compare that with what we have here, x is equal to tangent of y, we're thinking tangent of what angle gives us negative 1? Well, remember that tangent is defined to be y over x in the unit circle, so we're looking for ordered pair where y over x is equal to negative 1. Well, if it's negative, we know it's going to be down at quadrant 4, because our only choices are 1 and 4. Do you see how this is going to be this ordered pair here? Because if we take negative root 2 over 2 divided by root 2 over 2, we're going to get negative. We have 7 pi over 4 for the angle, but since we're restricted from negative pi over 2 to pi over 2, we'll have to subtract 2 pi from that, and we will get negative pi over 4. So that's how we get this negative pi over 4. Then the next one, we have negative root 3 over 3. If I rationalize the numerator, this is the same thing as negative 1 over root 3. Let's look at for this instead on the unit circle. It's negative, it's going to be down in the fourth quadrant. And this is negative 1 over root 3. If I take y over x, you see how it'll be this ordered pair that we're looking for because the 2's will divide out. Here we have 11 pi over 6. That's not within the domain, but if I subtract 2 pi to find a coterminal angle, you see that's negative pi over 6, and that's what we have here for y. If x is equal to 0, that means the ratio of y to x is 0. So y over x is 0, 0 over 1 is 0, that's it. And so then the angle is 0 radians. And that's what we have here. Root 3 over 3 is the same thing as 1 over root 3, if I rationalize the numerator. If I look for it, it's positive, so it's going to be up in the first quadrant. 1 over root 3, when we take the ratio of y to x, because we're working with tangent, you can see that's this ordered pair, 1 over root 3, is the same thing as pi over 6 for the coterminal angle. We got pi over 6 there for y. And then 1, if x is equal to 1, that means the ratio of y to x on the unit circle is 1. That's going to be root 2 over 2, root 2 over 2. And then the corresponding angle is pi over 4, and we see that's what we have here for y. Another way to think of it is, if you look at the graph of the function of tangent of x, do you see how we have 0, 0? Well, we could interchange 0, 0. We're still going to have 0, 0 on the inverse function. And then at pi over 4, it's 1. If we go to the inverse function's 1 and then pi over 4. And then at negative pi over 4, we have negative 1. So here at negative 1, we have negative pi over 4. So that's that point there. So you can just switch those values and you see that you get inverse tangent. Let's look at the graph of inverse tangents. We're going to look at this graph here to find the domain. Left to right, it's going to be all real numbers. The range, we read from bottom to top. It doesn't include the boundaries there. So we have negative pi over 2 to pi over 2. And it doesn't include them, so make sure you have parentheses and not brackets around that. The inverse tangent function is increasing from negative infinity to positive infinity, and it's also continuous for all real numbers. Its x and y intercepts are both 0, 0. It's symmetric with respect to the origin, so the function is an odd function. And for all x in the domain, inverse tangent of negative x is equal to negative inverse tangent of x. And then the lines y is equal to pi over 2 and y is equal to negative pi over 2 are horizontal asymptotes. You can see that there in this graph here. I think you understand how to use the unit circle to come up with values, and that's what you're going to be doing for your homework, not only in this section, but also in the rest of chapter 6. You can try to remember what the graph looks like. You can even refer to your notes when you want to see what this graph is, but what we're going to do is mostly just use the unit circle to come up with the values, or calculators too. The other inverse circular functions, we're not really going to work with this much. You will need to be able to figure them out, but I wouldn't worry about remembering what these graphs look like. One thing to watch out for with the inverse cotangent versus inverse tangent. So inverse tangent goes from negative pi over 2 to pi over 2 for the range, but for cotangent it goes from 0 to pi for the range. And you can see that here with this graph. If we don't choose that range, it's not 1 to 1, so that's why the range is different there. Inverse secant is this graph here, and then inverse cosecant. It's like this. For the inverse secant, this goes from 0 to pi, which is the same as cosine, inverse cosine. And then the inverse cosecant has the same range as inverse sine.